Hello everyone. So far we have discussed the two different types of velocities. One was uniform velocity and the other one was non-uniform velocity or non-uniform velocity. Okay. So the difference was in uniform velocity, the acceleration was not required because that is what uniform velocity means. Something which does not accelerate, its velocity remains constant. We call it uniform velocity. But the latter example that I gave you, in this example, this object was changing its velocity with respect to time. Okay, so this is in this topic we'll be talking about acceleration. Okay, so here acceleration comes into play. Now let us discuss what do you mean by acceleration. The change in velocity with respect to time, the change in speed of an object or a body with respect to time will be called acceleration. Okay, so the first thing to remember is the initial velocity and the final velocity will not be the same. Okay, and the acceleration in this case will not be zero. Let us discuss how. Okay, there are some lines written here, you have to ignore them because after talking about acceleration I will discuss further about this thing. Okay, now let us look at this example. Okay, this object right now at time t equals to 0 is at rest. I push it. Okay, I pushed it, I applied a little force on it, and after t seconds it gained a velocity of 10 meters per second. Okay, the velocity changed at t equals to 0. The initial velocity, and please do notice how am I writing. These are the convention in physics. Okay, you will always represent the starting or initial velocity. We will represent always the final velocity. Okay, the velocity at the time of your calculation. Okay, so at t equals to 0 you pushed an object after t seconds. After t seconds, t could be anything again. Okay, you have to take it into consideration. T could be anything. At t equals to 0 the velocity was 0, and when I applied a force on it, I pushed it, it gained a velocity of 10 meters per second in some amount of time. Okay, we do not know how much time it is. After t seconds, it gained a velocity of 10 meters per second. So how I'll explain, how I'll try to write acceleration is, acceleration will be equal to my final velocity, my minus the initial velocity, divided by the time taken by the object. So right now here it is very ambiguous, it is very unclear how much time did it take. So just for the sake of simplicity, I will take t as in t, the time taken by the object to go from 0 meters per second to 10 meters per second was, I took it as 10 seconds. Okay, so the acceleration is final velocity. Can you see how much is the final velocity? It is 10 meters per second minus the initial velocity, which was 0 meters per second. If you can see, my initial velocity was 0 meters per second. So 10 minus 0 becomes 10 upon, and I took it as 10 seconds. In this much time, in 10 seconds, the velocity became from 0 meter per second to 10 meter per second, which means 10 over 10, 10 meters per second upon 10 second, which is 10 cancels, 0 cancels out by 0. So acceleration becomes 1 meter. And do notice how I'm writing this as second square. Okay, because there was already a second in the numerator, it came down and it multiplied with this second, so the acceleration will become second square. Okay, so the acceleration right now here is 1 meter per second square, and this is an example of non-uniform acceleration. Okay, now this is acceleration, and this doesn't necessarily have to be, the initial condition does not have to be 0 meter per second. The initial velocity could be anything. Okay, it can be 20 meters per second, it can be 30 meters per second. It doesn't necessarily have to be zero. It can be something on the basis of which you will be calculating your final results. So right now what I took is, this object was not moving, this object was at rest. I applied a force, it started moving, and within 10 seconds it achieved a speed of 10 meters per second. Okay, so that is how I say my acceleration was 1 meter per second. Now look at this line. An object with uniform velocity does not accelerate, and also negative acceleration is called retardation. Now let us suppose, what I'll do is, suppose this is 0 meters per second and this is 10. So final velocity 10 minus 0. Let us say this object was already moving at a speed of 20 meters per second. Okay, and then after 10 seconds the final velocity became 10 meters per second. So here, if I do 10 minus 20, which becomes minus 10 upon 10 seconds, the sign here will become minus 1. So which means it was already at a higher speed, and something happened that its speed became less after 10 seconds. Okay, its speed became less after 10 seconds. That case, we will not call it as acceleration, we will call it as retardation. Okay, if your acceleration, and if the acceleration is negative, that means the force of action is in the opposite direction of the motion. So which basically means this object was moving is in this direction already with a speed of 20 meters per second, and a force applied on this object was in the opposite direction. That is the reason it slowed down. Okay, initially it was 20 meters per second, and if I apply a force on it, its speed will definitely go down, and the sign here will become that of negative, it will become minus. Okay, thank you so much.